exclusives, exclusive gates, and so on. So by Wednesday, which is 4 to 6 p.m., so we will have our prelim exam. So our prelim exam covers binary codes and Carnomap. Okay? So pure problem solving, no any conceptual items for the exam. So I advise that you need to practice how to do the Carnomap. Okay? So find or study the website, our reference for logic, so that you can enhance your skills in Carnomap. Okay? So I will share my screen for so can you see my screen here? Man? Okay. So logic gates and related devices. So device implement in the logic circuit. So when we say logic gates, it is an electronic circuits that can be used to implement most elementary logic expressions. So the Boolean expressions. So we are done with the canonical forms, okay, the sigma, and by nomenclature. So the equation with the complements. So it is already the combinations of all of this. So logic gates. So the logic gate is the most basic building block of combinational logic. So there are three basic logic gates: sa or, and not gate. Okay. So other logic gates that are derived from these basic gates are the NAND gate, NOR gate, exclusive or and exclusive NOR gate. So we will define the truth table for this specific types of logic gates. So positive and negative logic. So I will not further read this. So it's just the representation. For positive logic, if we have output of 1, it is logic high. And if there is no voltage here or there is no output in the circuit or in the logic circuit, the logic level is low. So take it as 1 and 0, 1 for high and 0 for low. So for negative logic, so we have just opposite what is in the positive logic. So if there is a voltage value, take it as logic low. And if the voltage in the negative logic is 0, it is logic high. Okay. So this is the truth table wherein A and B is our input. And if there is the gates that we're talking about, there is only one output, Y. So this is example of a truth table. So this table shows that so for this table shows that this is a 4-bit 4-bit logic. So we have four uh, rows for the values wherein um, if we have two inputs, A and B, so we just use the formula where we just use 2 raised to n. So we can know the rows of this table. So 2 raised to n, where in n is equal to 2 because of input of A and B. So 2 raised to 2 is equal to 4, uh, 4 rows. So expect that we have here 0, 0, and then 1, 1, 0, 1, and 0, 1. So it is already the order uh, of the table for 4A, or the first column is two zeros and two ones, and then B alternating zeros and ones. And then depending on the output given, so it is written here in our third unit. So this one, if we have three inputs, so let's consider 2 raised to 3 is equal to 8 rows. So in that, if we have, um, if in the first column, if it's 8 bits, so we divide it into 2. So it's 4 zeros and 4 ones. Then on the second column, it's 2 zeros and 2 ones. And for letter C, it's alternating zeros and ones. And then the output is depending of what is in the given. So that is the truth table. So logic gates. So this is the schematic diagram for NOT gate. So this is a single input. It also has a single output. So output is the complement of the input, meaning it's the opposite. Okay. So this is the schematic for NOT gate. So triangle with bubble. Okay. So next. So not function if the input is 0, the output is 1, reciprocal reciprocal. Vice versa of this, if the input is 1, the output is 0. It's just the opposite of what is in the input, the output is different or the opposite. Okay. So OR gate. So OR gate, we have multiple inputs. So minimum of 2 inputs. So incrementing by 2. So single output. Then output is high if any input is high. So this is the schematic for OR gate. Next is OR function. So just remember for OR, if there is one input, the output is already high. So this is the definition for this one. Output is high if any input is high. So if there is one in the input, all of the output is also one or high. So next is the AND gate. AND gate is same as the OR, multiple input. You have the single output. So output is high if all inputs are high. Is that correct? No, output is low. All inputs are low. So the PowerPoint is wrong. So for AND, there is a 0 in the input. All of the values are all zeros, except that if it's both 1, that the output will only be 1 or 5. This. This is the schematic for AND gate. Okay. So for AND function, yeah. So if there is an input that is 0, the output is 0. Except that if both inputs are 1, the output is 1. Okay. So just a short review before this one. Okay. So next is NOR. So additional gate that you need to remember or you need to understand. NOR gate, multiple input.
Unveil the essence of pure hydration.
Is high if all inputs are true. Okay. So just
New era of luxury skincare begins. Experience the exquisite texture meticulously crafted for your
is also considered as not OR. It means that if we know OR, we're in any input, any input of 1, output is 1. So ignore if any input is 1, output is 0. So just the opposite of what is in the OR gate. Okay? This is the NOR gate. So just remember the schematic for NOR gate indicates bubble. So indicates that it is not OR. Okay? So the opposite of what is the value or the output for the OR part. So it can be also written like this. Since this is a NOT gate, this is an OR gate. So if we combine these two, this is the NOR gate. So we just separate the schematics to understand that the NOR gate is not OR. So next. So the NOR function. So just the opposite of the outputs. So in the OR, it's OR, this is 0, this is 1, 1, 1. So this is for the NOR, just the opposite of the OR 2. Okay, so next, NAND gate. So NAND gate, multiple input, single output. If the output is low, if all inputs are high. So this is not AND. So same as the concept for NOR gate. So if for the AND, so for the AND, if we have input, any input of 0, um, all output, all output are input of 0, all output of 0. So now for NAND, this is the opposite. If the input, there's an input of 0, or in all outputs are 1. So let's have here the schematics for NAND gate. So this is also the equivalent for NAND gate. And this is the function or the truth value of the NAND gate. So as you can notice, if both um if both of the inputs are low, so the output is 1 or high. So if there is any value that is both zeros or any of the inputs are zeros, output is 1. So if the inputs are both ones or both highs, so it will become low. Okay, just remember the truth table equivalent for each of the logic gates. So this you can find the references in our website. So it is in the module already. Okay. Next is XOR or exclusive OR gate. So this is exclusive OR. Multiple input, single output again. So output is high if the one in the input are up. So this is the schematic for XOR. It's just an OR gate. We just add another line here indicating that this is an exclusive OR gate. So this is the truth table. Okay. So just notice here that if both inputs are both low, the output is low. If the both inputs are ones, the value or the output is both 0. So if the inputs are different from each other, the output is high. So that is for the XOR. Okay. So next, is XNOR. So exclusive NOR, multiple input, single output. So output is high if the one and the input are even. Okay? So just the opposite of what is in the NOR gate. So this is not XOR. Okay. So this is the schematic. Just add the bubble at the end. Okay. Schematic. So it is just a NOR gate, uh, XOR gate, XOR gate. Just add the bubbles. It can be or can become XNOR. So this is also the schematic separated for from the NOT gate. So this is the um, truth table. Okay, if both inputs are zeros, so the output is high. If both inputs are one, it is also high. If the inputs are different from each other, it is zero, just opposite of what is in the X or Y. So next, alternate symbols. So this is the alternative method or alternative symbol for NOT gate. I will just flash it. So, hindi naman na kailangan i-explain ko since ito naman ay just an illustration. So, no explanation needed. So, this is for the OR. Okay. Uh, yeah, it's for the OR game. You can add bubbles to the input and add it again or add the bubble again for the output. It's just equivalent for this. Alright. So, a bubble of from the AND, add all the bubbles here from the input and bubbles for the output. So you can get the value for OR gate. So that is the equivalent schematic diagram. Next. So if it is AND gate, it is equivalent to the OR gate having bubbles on the input, both of the input, and also for the output. Next. So if it is a NOR gate, so it is just an AND gate with both inputs have bubbles or um, it's different. It's not gate. So if there's a bubble, so example, if your input is 1, if it goes through this logic gate, it will become 0. So if it is 0, if going through this gate, it will become 1. And then the equivalent for AND, 0 and 1 is, the output is, what is the output? Anyone? Hello, anyone can answer what is the AND equivalent for 0 and 1 as an input? Ano sagot? For sure, zero daw yun. So the answer here is zero. Okay, just the, if any input is zero, answer is zero. But output is okay. You understand why this happens? Okay. Sige sa pa, pagka hindi pa rin kayo sumagot, kaya ko yung mag-aral nito. Important. Sayang naman ang discussion kung wala naman din sasagot. Diba? So, none. So, I will not have any example and further so that we can continue with our discussion. Okay? Wala naman din sasagot. So, A and B input. So, the output is have the bubble. So, this is NAND gate. So, it's just the equivalent of the OR gate with the bubble on both of the input. Okay? So, NAND gate. So, alternative symbol. So, I will not read this further. So, it's just a representation. Okay. So, so for the interpretation, if both of the inputs are active high, so expect that the output is in the active low. If there is a bubble presented in this logic circuit or logic, and if our input is an active low or there's a bubble on the both of the inputs, so the output will become active high if using OR gate. And this is for the AND gate. Okay? Choose the bubble. Whenever possible, choose the gate symbol so that the bubble outputs are connected to the bubble inputs. The non-bubble output to non-bubble inputs. Okay. So this is the equivalent symbol for IEEE and C standard. So you can use this diagrams or symbols if you're going to publish a, a journal review or journal or a research paper. And
Is dry
if
skin a
you're
constant
going
concern?
to
Discover the secret to lasting hydration.
development of
Experience a transformation
you
with
can
our
use this
luxurious
as the standard equivalent. Okay. So next, universal gates. So this is the universal gate. So this is the equivalent. So if it is not gate, you can use AND gate. And if there is one input, so you can have this.
Welcome to Create.
Has multiple inputs. So
Welcome to
minimum
creating
inputs.
voiceovers.
So if you only have one
Welcome to
input,
creating voiceover. Welcome to creating
this both inputs
voiceovers.
can be
Welcome to
combined
Creating
here.
Voiceovers.
So yung AND gate ay meron din yung bubble indicating that this is the opposite AND gate. So the output is the Y. So if there is two input already in the AND gate, so you can rewrite this or redraw equation or the logic circuit by having the bubble on the side. Okay. So this is the opposite. And then if you enter this, it will become a NOT gate. So this is the opposite of what is the opposite. It's the AND gate. So this further uh, equivalent of the gates. So this is for the NOR.
Is dry skin a constant concern? Discover the secret to
So this is the equivalent circuit. Okay. So next is the NOR gate. So this is the equivalent circuit diagram for NOR gate. So later on, we will have our example here so you can further understand of this equivalent or universal gates. Okay. So other gates. So this is the inhibit gate. So I will just show you the representation and not further on the conceptual part since it is already given in your references. Your reference, the website, okay, the module. So this is the gates with open collector drain outputs. So this is the wire end connection. So we use both of the three NOT widths while having pull up resistor here so we can have this output. So tri-state logic widths. So there is a pin that is called enable. So further discussion for this is also included in your references, in your reference. Okay. Tri-state logic gates. So both or all of these three NOT gate has an extra pin for enable. So tri-state logics. So and or invert gates. So this is um the circuit. And this is the out. Or and invert gates. So notice this as this is the SOP, right? And this is the POS. Okay. So I will not discuss this further. It's also included in your reference. Inverter response. Inverter response. For Schmidt gates, I will not discuss this further. Complementary gates. Buffers. So transceivers. So application. So application of the OR gate. So this is the detection of one or more occurrence of events in a plant. So here, if you want to detect something in your plant, so if there is a temperature and pressure sensors, so um if the temperature read has this not heat as the comparator, so this is the reference temperature. So if the temperature does not meet the reference temperature, it will go shut down or it will go down. So also for the pressure sensor, so this is the pressure reading. So this is the input on the positive side. And if the reference pressure does not match either high or low, it will go down as well. So that is the detection for the OR gate or application of the OR gate. Once that the temperature or pressure sensors does not meet the reference parameters or reference values, it will go down or it will go to shut down. Otherwise, it's not or it will still become active. So, gagana pa rin siya kahit ah, nagagana pa din or gagana naman talaga itong planta kung mamimit niya or kahit iset lang natin yung reference or with discrepancy of at least point something or just a small difference. Kung malaki na yung difference or incremental na or at least exponentially exponentially increasing, dramatically increasing or decreasing of the pressure or temperature reading, siya ay magsha-shutdown. Okay? Next is the ungate. For the ungate, so this is ungate as inhibit or enable. So if our inputs here is the clock and the gating pulse, and we have the application for ungate, it will enable the gate. So we can have our clock input. So for ungate. So for XOR and XNOR, we can have the application for parity generator. So what is a parity generator? So I will just search for what is parity generator. So parity generators, combinational logic circuit used to generate parity bit for a given set of binary. So yung mga parity, yung mga complements, kasama mo dyan, even and odd parity. So XOR is used for this because XOR outputs 1 when the output of ones is on. So this is the application for XOR and XOR game. So inverter. So inverter, so this is used for square wave oscillator. So square wave oscillator. So this is an electronic circuit wherein the output waveform will become square shape. So what is the meaning if there is a square wave in our periodic waveform? So it converts DC power into alternating square wave signal. So the output alternates between high and low voltage levels at a specific frequency. So most of the application for square wave oscillators is for digital clocks, timers, microprocessor systems, pulse generators, and signal generators. So this is a very important application for invert. So square wave oscillator. So this is an oscillator with external components. So it may vary to your requirement or required parameter if you want to use inverter. So depending on the application. So can be on appliances or on a larger scale industrial systems. You can use this depend on your required parameters. So if with external components like resistance and capacitance. So next, so Schmidt oscillator. So Schmidt oscillator. So Schmidt oscillator. So it is also forms a square wave oscillator or square wave output. So it is a continuous one. So a trigger circuit with an RC network. So there's a resistance and capacitance involved. So what is the use of this Schmidt oscillator? So it is widely used for digital electronics and timing circuits because it provides stable switching and noise immunity. So yeah, remember that we have here the components. It is called a Schmidt oscillator. if we have RC network, resistance and capacitance and its inverter equivalent. Okay? So, um, so we're done here with Schmidt oscillator. So just the application for this is clock signal generation, pulse generation, signal conditioning, so the bouncing circuit, so microcontroller timing circuit. Okay. So next. Yeah. So some of our exercises, so I'll give you some example for um on how you create logic circuit. Okay. So wait. So for a moment lang, check ko yung sinend ko kay kay class rep yung OneNote. So, open ko lang yun. And yung magiging basis natin for the example for logic circuit is uh, our discussion on the Carnot map. Okay. So, it is interrelated. Wait lang.
natin po ay ano, yung pong halimbawa po yung dalawa pong and muna gagawing kukonek po sa or tapos dalawa pong nasa ilalim na and yung, itong one side yung pong dalawang or ay kukonek naman po sa pin.
Wait lang, medyo nalito ako doon. Paano? Pwede mo bang drawing? Para kita ko.
Try ka po mag-open sir.
Oo, sige, sige. Try ko para assess ko. Pwede yun. Ipipin kita para maganda.
Abo sir, hindi lang po ma-rotate ang camera.
Galang, galang.
So, sa ako naman yung gusto yan. Sir, excuse po, nakikita niyo po.
Ayan.
Okay. So, watch natin po.
Ano na lang, picturean mo, send mo sa email para ma-flash. Kung nahirapan ka, picture. Okay. Multiple cores. Yan, pwede rin yan. Mas maganda nga yan kasi mas makikita natin represented na meron yung kayang to input na word yun. Ito yan.
Sige. Sige po, sir.
Okay. See you. Questions pa before we proceed, at least one example na lang tayo for POS naman. Okay na? Klaro tayo? I-erase ko na to. See. So, our example. So, this equation will be based on our discussion on Carnot maps. So, kukuha lang ako ng equation doon. Okay. So, one equation. Okay. So, sa SOP naman ako po. So, sige. Ganito. So, kuhakin. So, example, we have our equation here. Y is equal to A complement plus C complement plus D times A plus B complement times A complement plus C. So, paano naman yan gagawin? So, we have four inputs, A, B, C, and D. So, sige. So, meron tayong tatlo dito na parts. So, unahin natin itong una. So, A complement. So, A complement. So, itong A na to, i-plot natin dito. And then, insert the not gate. So, since it's A complement. C complement. So, here, C naman. And then, not gate. And then, D. So, we have here three inputs. Three inputs of OR. So this is an OR group. Okay. So next is this part naman, yung A plus B complement. So A, and then B complement. So B complement, so siya yung not gate. So output natin dito ay OR gate din. And yung panghuli is A complement. Ito naman, A complement. So not gate. Then C. So yung C naman, ito. So meron tayong 2 input na OR. So ito, magkakaroon tayo dito ng 3 inputs. 3 inputs of AND gate. So AND gate. Okay, so this is the output 1. So ganyan lang pagka naman POS. Kasi tawag nito. So ganun lang pagka POS naman, ang mangyayari naman dito, since ang sabi nga natin, pagka product naka or tama ba? And then yung ating sub, ay mga ba to? Bakit hindi? Wait. Baliktad pala, baliktad. Dito nakagad ako. So, pag product, ito yung and. Gagamitin. And then, pag nakasum, siya yung naka-or. So, remember this. So, lahat to naka-plus, nasa loob. So, siya ay naka-or. Tapos, yung product, so, lahat yan ay naka-product. So, ikinombine lang natin siya into one and gate. Okay? So, kabaliktaran naman ang mangyayari pagka product of sum. Naintindihan ko? Okay. So, meron akong magiging assignment sa inyo nito. So, na-share ba sa inyo ni Karen yung discussion? Yung yung OneNote, yung PDF? Sinend ko kasi sa kanya. Nakatanggap ba kayo? Ayan. So, lahat ng equation doon, gawa nyo ng Carnot. Ay, ng Carnot, ng logic circuit. Equivalent. Lahat yun, yung nasa example natin. Ano? So sabay, hindi pa naman siya, pasa ko na ba siya? Kasi baka malito naman kayo kasi ang prelims naman natin ay hanggang Carnum lang. So next week na lang yun, no? Next week, assignment na yun. Ano, nagawin ninyo logic, circuits, lahat ng example natin dun sa Carnum na discussion natin. Okay? Naintindihan? Okay. Huwag kakalimot next week yun. Kung ka makalimot, lalab na lang. So, prelims tayo on Wednesday. Ang coverage, binary codes, at saka Carnum. And the next week, nga pala, i-advance ko na din, ano, for next week, tayo ay magla-laboratory. Laboratory number 1, and then ipopost ko na lang. So, plano kong gumawa nga pala ng panibagong Google Classroom. No? So, mag-join na lang kayo doon. So, once na ako ay nakapag, tawag dito. Nakisingit ko sa oras ko na gumawa ng Google Classroom na panibago. Ano, yun. Isasend ko rin kay class rep, kay Karel yung yung materials na bibilhin ninyo. So, among ICs yun. So, para makonduct nyo na yung experiment number 1 next week. Okay. Ayan. Kasi, ang mangyayari, last exam na natin po, yung prelim sa Wednesday. Dahil, plano ko na lahat kayo ay practical exam na lang for midterms and finals. And, ang gagawin ko sa inyo, no, so babaguhin natin yung sinabi ni Doc Sam na ano bang sabi sa inyo? Pagka-laboratory per group, tama ba? Pwede ko i-confirm kung yun nga ba yun? Anong pagkakasabi sa inyo? Mag-laboratory per group? By pair, yun. Yun pa rin pala, no? By pair ang laboratory. And yung exam, practical exam, by pair din. So, nakapili na ba kayo ng pair ninyo? Or may pairings na ba kayo? Sure na ba kayo dyan? Baka mamaya may magrereklamo sa akin, hindi po natulong si hindi natulong si ganyan. Ako lang po ang gumawa. Nagpuyat po ako lang po ang tulog. Siya po ang tulog, ako pong gawa ng gawa. Ayun. So, maganda naman din, may free will kayo at kayo ang mismong gumawa or pumili ng kapares nyo. So, practical exam, laboratory, or by pairs. May final exam, may final project kayo, no? Iniisip ko kung ang gagawin pa natin ay yung 8-bit computer kasi hindi ko masyadong nagigets yun kung paano yung ginagawa. Ewan ko kung na-search na yun kung paano gagawin. So, ang plano ko by your final project is also by pair. No? So, magkakasama talaga yung pares na yan sa hirap at ginhawa. Kung sakaling may magkatuluyan diyan, makakapang kunin yung lugo. Diba? So, sa lahat ng gagawin ninyo, puro kayo prepare. Kaya siguraduhin niyo na yung pares ninyo ay siya na mismo hanggang sa dulo ng semester. Huwag naman forever. Magkakilala mo kung gusto forever. Ayan. Mga klase na lang kayo since first year, ewan ko lang kung may mga nagka-development dyan. Di ba? Ayan. No? So, pag-iisipan ko pa kung paano magiging final project setup ninyo. I'm sure na siya ay by pair. No? And then, i-defend mo siya. No? Bakit ganito yung ginawa ninyo? Bakit ganito yung circuit na ginawa ninyo? So, meron tayong i-invite na some of our faculty members na magja-judge ng inyong circuit list. Okay? Yeah. So questions, clarifications before we end up. Before. Clear naman na? Okay na? Wala na ba? So, sige. Kung wala na, again, early dismissal tayo. So, late na tayo nagsimula pero early dismissal. Since ito lang naman talaga yung intended na i-discuss ko. Okay? So, kung wala naman na tayong tanong, so class dismiss, see you on Wednesday. So, wala tayong meeting na Tuesday bukas na yung 1 hour. Wag na. Wednesday na tayo sunod. Okay? Sige, bye-bye.